So first off, if you have any questions or topics that you want to go over today really quick, go ahead and start typing them out in chat now. Otherwise, I have a couple things planned out below this, and I tried to make some questions that go over a large variety of topics. Anyway, so a few notes about your final. So your final is Monday, so next week, at 12:30 p.m. Note the slight time difference. It's off by half an hour. The exam's going to be on Blackboard under the assignment tab, so if you've taken any quizzes or whatever on Blackboard for me, they'll be exactly in the same spot. I'm going to be putting up a mock exam, probably just made of really old quiz questions, just so that you can get a feel for the layout if you haven't seen one of my assessments on Blackboard before. The final will consist mainly of multiple choice, true, false, and maybe even some matching, some things that are going to be actually gradable by Blackboard in ways that it won't screw it up. There will be some free response, but those are probably going to be much scarcer. There probably will be some find the error questions. I'm probably going to do those a tiny bit different than you've seen on the exam before, where I'll give you the work where you have to find the error and I'll just say, there's one error here, tell me what line it occurs in and tell me why it's an error or something like that. So I'll tell you how many errors and you'll just have to find where they are. Someone already asked in chat, do you need to show work? For the most part, probably not. I haven't fully written the exam yet, so some things are still kind of up in the air a little bit. But if there's anything that I kind of want you to show work on, it'll probably be something like a Riemann sum, where I want you to actually type out the sum that you calculate instead of just the answer. But I'm going to try to avoid the questions where I would want you to show a ton of work. So again, it'll probably be a bit more multiple choice, kind of not free response. There will be some free response, but not as many. This exam is going to be open note, open resource. And now what that means is that you can use any previously available resources for your exam. So your notes, so the lecture recordings, so anything you can already find on Google. What that does not mean is that you cannot post questions online to receive help. So you can't put the question on Chegg, Reddit, Stack Exchange, whatever the heck. So you can't put the questions online for someone to answer them for you. But if you Google and you find a similar question or something like that, and you want to use it to help you determine the correct answer, that's perfectly fine. The exam period is 2.5 hours. I usually try to write about an hour and 45-minute exam. So in terms of your usual exams, it'll be about twice the amount, twice the size in a way. Anyone who has documented extra, that should say time, not tile, extra time, will receive it through Blackboard automatically. Well, I have to set it up. So if you open your exam and you're supposed to get extra time and it doesn't say that you have extra time, conflicting changes. Just change it. Anyway, so if you're supposed to receive extra time and it's not showing it for you, close it out immediately and let me know. During that exam time, I will be on Teams. You do not have to be there, but I will be here on Teams in case you want to pop in real quick and have a question. I'll also be checking my email frequently. So again, you don't have to be here for the exam. I'm like, you don't have to be here. But I will be here if you have questions during that time. For the rest of this week, I'm going to have some office hours Wednesday from 12 to 2 because today's our last class, so we don't have class on Wednesday or Friday. So Wednesday from 12 to 2 and Thursday from 1:30 to 3:30, I'll be in my office hour team. If you haven't gotten into my office hours team already and plan to be there, you'll need this code down here. And on Teams, there's like a thing on the side where if you go to the Teams tab and it says join and you can put in a little code. Anyway, I'll be putting that information about the office hours up later today in case you need it later, but that's the thing. Okay, questions, concerns about the exam in general, or any last minute call for any topics you want me to go over before we just start going over what I prepared? I'll give people like 30 seconds in case people are typing out something in chat. All right. Okay. Okay, so let's just start going over some of the stuff that I have. I'll put this up on Blackboard. We'll get through as much of it as we can, and if we don't get through the rest of it, I'll put the rest of the answers and put it on Blackboard. The exam review, I should say this, just got up like literally half an hour ago. Well, at least I think I did put it there, right? Yeah, I'm pretty gosh darn sure. So the final exam review is up in the usual exam place. I'll be getting exam 2 and exam 3 answers up when I can. Those never got up, so I'll get those up when I have a chance. But other than that, the final exam review answers will be up as soon as I can. It's on my to-do list for today, but it might take till tomorrow to get them up. But they'll be up as soon as I can. All right, let's get started. So we open a bank account with $5,000 and the account earns 2% interest annually. The first thing we want to write is an equation for the amount you have after T years. So this is starting with some chapter 1 material. So this is back to exponential functions. Let me share my screen one more time just in case. No one said anything, but let me just in case. All right. So back to exponential equations. So remember we have, let me kind of do some notes off to the side here. We have two different forms for an exponential equations. We have P naught a to the t, and remember that's made up of 1 plus r, and then P naught e to the kt, where the k is just the rate. And remember that this form, the e to the kt, is used when you see the word continuous. If you don't see the word continuous, you use, well, if you don't see the word continuous and you see the word rate, without the word continuous attached to it, then you use the a to the t. If you don't see the word rate or the word continuous, that's where you could choose. But I would just personally default to the a to the t if you don't see continuous. But anyway, so here, since it says annually and it doesn't say continuous, we want the a to the t term. So we want to write an equation that looks like this. So our initial amounts, remember that's the P naught, that's going to be our 5,000. And since we're told 2%, that's going to be how we find the A value. So the R value is 0.02 because remember you have to change the 2% over to a decimal. So 2% into a decimal is 0.02. Which means, oh, I should also slow down a little bit because I know you guys don't have this. So I'll slow down a little bit in case people are trying to write down that beginning part of that. And I'll try to pause every once in a while to make sure you can get those down. So we have our R value. We can use that to find the A value. So remember, we take that R value and we just add 1 to it to get our A. So 1 plus R. So 1.02 will be our A value. So the equation we're looking for is 5,000, 1.02 to the T. And then we want to know how much will we have after 10 years and how long until we have $500. So there's two separate questions. I'll wait like 5 seconds in case people are writing down that part of the question. So how much will we have after 10 years and how long until we have $7,500? So how much will we have after 10 years? That's essentially just a plug and chug. We take this equation we just found, and since time is our T value, we're going to plug in 10. And I need to figure out what that is. Once my calculator turns on, there we go. 5,000 times 1.02 to the 10th power is 6,094. And since it's money, let's just make it 97 cents. So since we just wanted to know the final amount after 10 years, it was just plugging it in. So yeah, so Kayla, what I'm doing now isn't posted anywhere. So I'm going to try to pause every once in a while in case people want to write down the question that we're going over. The official exam review is up on Blackboard. So this we're just doing for class today to help review, and this will be posted to Blackboard after the fact, but is not there now. But the final exam review is. So that's different so that you guys can focus on doing that on your own time. Similar type of questions every once in a while, but that also covers more stuff than we'll cover today. Anyway, so we have how much it was after 10 years, but now we want to know how long until we have $7,500. So instead of plugging in for T, we want to essentially set this equation equal to 7,500. and solve for t. Now this is a way back when flashback. So we want to solve for t. So for this is when we have to use our natural log process. So we essentially have to isolate the thing with the exponent, and then we have to natural log both sides. So to isolate the thing with the exponent, we have to divide both sides by that 5,000, sorry. Also, as always, stop me if I'm going too fast. So we have to divide both sides by that 5,000. So 7,500 divided by 5,000 is 15. That's good. I didn't know it was going to turn out to be such a nice number. I'm going to run out of space if I don't start writing smaller. Let me actually that again. And then once you have the thing with the exponent isolated, can't see it? I can reshare my screen. Doop-a-doop-a-doop. You should be able to see it now. Let me know if that is not the case. So now that we have the exponent, the thing with the exponent isolated, we can take the natural log of both sides. So we have the natural log of 15 equals the natural log of 1.02 to the, whoops, to the t. And I'm still going to run out of space. And remember, the point of doing that is that we have this, this natural log rule that says if we have the natural log of something to a power, we can bring the power outside of the natural log. So the point, I'm going to run out of space, is that we can bring that t into the front. And now I want to get t by itself, so we'll essentially divide both sides by the natural log of 1.2. So I'm going to put the t over here so that I can kind of write two things at once. So the natural log of 15 divided by the natural log of 1.02. And then you would punch that into a calculator. Natural log 1.02 is approximately 136.75. Questions, concerns on that? It's been a long time since we did one of those. All right. I'll wait a couple seconds before I move on. Oh, yeah, I should probably put units on that, shouldn't I? Wait, 7.5. Yeah, so since this is a t value, it's going to be in years, so it will, that seems like a very long time. Well, 2% isn't a lot of percent, so it's going to take 137 years. Should it? Oh, Lord. Yes, yes, it should. I typed it into my calculator. I missed a 0 when I typed it into my calculator. No wonder it seemed like such a large number. Because it shouldn't have been. Thank you. So, oh, Lord. Equals. I typed this into my calculator wrong. And it should be 1.5. Which gives the natural log of 1.5 divided by the natural log of 1.02. That makes a little more sense. Okay. I was a bit concerned there. Thank you for catching that, Mason. It should be 1.5 instead of 15 everywhere. All right. Sorry about that. But that is, so I mentioned before that I'm going to try to avoid questions where I require you to show work. But feel free to, I'll probably have a separate thing on Blackboard for you to post any scratch paper you have. Feel free to upload your scratch paper, because if it was a question like this and you got, what did I get before, 136? But I could see where that came from, then you'd get much more points than if you just had 136 and I had no idea where it came from. But anyway, so feel free to upload any scratch work from your exam. You don't have to, but I'll have that as an option. Anyway, moving on. So next is we're asked to write an equivalent equation with continuous interest. Kayla, so will we have the grade right away or will we have to wait? Since there will be some questions that will have to be graded by me, you won't get the official score right away, but you'll be able to see the grades for like how many of the multiple choice and all that stuff that you got right. So you can at least get an idea of how that went, but some of them will have to be still graded by me because the things that I'll have, so I would love Blackboard to grade it by itself. That would be amazing and I would love it. But when it comes to like free response questions, Blackboard is terrible, especially when it comes to math, because there's about 5 million different ways you could input it if it's got like exponents and everything, and I can't have it recognize all of them because sometimes people think of weird. Anyway, so you'll get part of your score back immediately, but not all of it because I'll need to grade some of it. Anyway. So write an equivalent equation for continuous interest. So remember, there's way back when we were first doing this, there was a homework question, and there's a reason I bolded this equivalent here. If it doesn't say the word equivalent, it just wants you to find the continuous equation. So if I said just find the equation for continuous interest, it would be different than this question. What this question is asking is it's asking us to take the form that we have and change it into the e to the kt form. So essentially, remember for this, essentially the only difference between these two forms is the a versus the e to the k. Everything else is the same. The p naught doesn't change, the t exponent doesn't change. So if we want to change this into its other form, the p naught is still going to be 5,000. But we're essentially going to take our a value of 1.02. And so to make these two things equal to each other, if the only things that are different are the a and the e to the k, we essentially want to set those two things equal to each other. So remember, when you want to switch between the two forms, this is kind of the thing you want to think of. A equals e to the k. So we have 1.02 equals e to the k, and we want to solve for k. So k here, since that's in the exponent, we'll have to take the natural log of both sides. And I brought out the k at the same time, so technically it would be natural log of e to the k, and then you bring the k out front. And then remember that the natural log of e is just 1, so that's 1. So we have the natural log of 1.02 equals k. We plug that into our calculator, and I'll make sure I do it correctly this time. Yep. So our k value is approximately 0.0198. Let's take 4 decimal places there. So the answer to this question would be 5,000 e to the 0.0198 t. And then we're going to use this equation for the rest of the questions, rest of the parts of this question. Questions, concerns about that? So that's the equivalent equation. If you don't see the word equivalent, then you just let the percent be the rate. Well, you change it over to a decimal, but. Okay. Let me keep, if this will scroll. Keep that part of the question in. So the next thing we're asked for is to find the rate at which the amount in your account is growing. So essentially, since we want the rate, that's essentially asking us for the derivative. We want to take the derivative of this equation. And again, as stated in the last problem, we're going to be using the e to the kt form from this point out. So we want to find the derivative of that equation. So we want to find p prime. So remember, when we're finding the derivative, if there's a constant out front, the constant just comes along for the ride. So that 5,000 just kind of chills. And then make sure you're trying to be careful of you know, because we have derivative rules and now we just learned antiderivative rules as well, try to keep them straight. But we want the regular derivative here. Now we have an e to the kt essentially. If you remember it as an e to the kt rule, you can do it like that. If you treat it as a chain rule, which it technically is, that's fine too. So the derivative of e to the something, remember, is e to the something. That's like our favorite rule because it just stays the same. But then we have to multiply by the derivative of the something. Oof. Oof. Can y'all hear me? Can you hear me, guys? Can you hear me now? You can hear me? Great. Okay. Yeah, my Wi-Fi just crapped out a little bit. Oh, it's still not good. Ooh, okay. Some people still can't. Okay, hold on one second. And let me even try. I'll be right back. Okay. Well, that's not good. There we go. All right, well, that was fun. Anyone who still can't hear me, try hanging up. I don't know why I'm saying it. If they can't hear me, they can't hear me. And coming back in. So I'll wait a couple seconds because some people have to do that. But hopefully, oh Lord, so is the recording is apparently still going? Okay. Whew. Well, that was fun. All right. Cool. All right, so where the heck were we? What were we doing? We were taking a derivative. All right. So we took the derivative of the e to the something, and then we needed to take the derivative of the something. So we essentially need to have that number come out front. So remember, you can view it as an e to the kt. It's technically a chain rule. On a scale of 1 to 10, how difficult do you think the exam is? That's a terrible question to ask me because I think all the exams are easy. But I also haven't officially written it yet. Since it's an open book, open resource, I don't want to say it's going to be harder than usual, but like there are different types of questions I can ask since you can use anything. But I never know how to answer that question because I always think the exams are easy, but that's because I know calculus really well. Anyway, let me multiply those two constants together. Oh, that comes out to something kind of nice. Comes out to 99 e to the 0.0198 t. Yeah. So that would be the rate at which the account is growing. We weren't asking anything more than to find the rate. That is the rate. It's in a question. It's in a question. It's in an equation. Sorry. And then we could, of course, ask more about it. Yeah, I don't think a lot of people like to exam too. But anyway, moving on. So next we're asked to find and interpret f of 5 and f prime of 5. Maybe I shouldn't have used f. Here I'm saying that f of t is the, is the original one with the E, 5,000, 0.0198 t, and now f prime of t. Sorry, I just wrote this like right before class, so I wasn't really thinking about notation. Is that. So we want to find and interpret those two things evaluated at 5. So if we find f of 5, I'm not going to write out the equation with 5 plugged in so that I don't run out of space. But you would just plug 5 into the equation with the 5,000 in it. So 5,000 times e to the 0.0198 times 5. Let me just write it out. 5,000, goodness gracious. Times 5. This is approximately 5520.33. And let me do it like this. Let me break it up like that. And then if we find f prime of 5, and then we'll interpret them, we'll plug in 5 to the derivative equation. 198 times 5. 99 times e to the 0.0198 times 5 is approximately 109.3, let's just say 30. So we've got those two values, and now we want to interpret them. And so the first one, f of 5, so that's just a regular old equation. That's essentially saying 5 years, 5520 is the amount that you have in your account after that time. So I would say something like you have $5,520.33 in your account after 5 years. Just the 5 years and then the amount. And then if I want to interpret f prime of 5, so remember we kind of have two different ways to interpret derivatives because they're a slope. We have the rate way and the slope way. So since we're doing kind of a review-ish thing, let me write them both. So if you want to do the rate way, remember you always when you start. So we essentially have to say after 5 years. So after 5 years. And then it's going to be growing since the derivative value is positive. So we can say the account is increasing, the account is growing, something to tell us that it's getting larger. So I'm going to say the account balance is account balance. I'm going to say is increasing. You could say is growing, whatever floats your boat. So is increasing by, and then that value 109.30. And this is essentially where we need the official units of the derivative. So the derivative is going to be essentially dollars per year here. So it's going to be this many. Let me just put dollars as a dollar sign per year. And then I'll hold on like 5 seconds before I write down the slope way. So the slope way would again have to start with after 5 years. You need to say something where if we increase by 1 more year, so each additional year, something like that. Each additional. This is a lot of concepts in one problem, Kayla. That's kind of how I made these problems on this kind of review thing that we're doing right now. I just tried to pack as many concepts in one problem as possible. So after 5 years, each additional year will increase the balance by 109.30. Yeah, yeah, it's a long question, but it's just because it's got lots of pieces with lots of different topics. And I will say that in terms of questions on a final, I do sometimes, maybe not this long, this one is a pretty long one, but sometimes I'll pack a few different topics into a question like this. But so yeah, we've pretty much started with chapter 1 material, and now it's got a little bit of chapter 2 material. And yeah. So I'll leave that up for a couple seconds before we move on to the next part. I think the next part is the last part for this question. Yeah. So remember, when it comes to interpreting, you would get to choose one or the other. You don't have to do both. But you always have to state where you start, whether or not you're increasing or decreasing. And if you're going by the rate way, you use the derivative units. And if you're using the slope way, you have to say you increase by an additional x value or t value in this case, and then the increase or decrease in the y values. So without using f of t, estimate f of 7 and f of 4. So essentially what we're going to use here, we're essentially trying to forget that we actually have the equations. So what we're going to use is we're going to use this f of 5 and this f prime of 5 that we just found. So we're going to use those to estimate f of 7 and f of 4. So again, I know we technically have the equations, but this is a type of question that I would usually give you without having the equations in them. I just put it in this question because it fit. So remember, if we want to estimate something and we're given an original value and a derivative value, we can use that original value and just keep tacking on derivative values until we get to the one that we want to estimate. So if we want to estimate f of 7, well, we have to start at f of 5 because that's the only one that we have in this situation. And then if we want to get from 5 to 7, well, that's 2 steps. So we essentially have to multiply 2 times the derivative value, because remember, the derivative is telling us if we increase by 1, how much the y values increase by. So if we need to increase by 2, we need to increase by twice the derivative value. So we have this 5520.33 plus 2 times 109.3. What is that? 5520.33 plus 2 times 109.3. 5,738.93 is our estimation for f of 7. So also remember that doing this process is a pure estimation. We don't know how great it is of an estimation. It could be really bad. It could be okay. The farther away you go from the initial value, the better estimation is probably going to be. And then if I want f of 4, well, I need to still start at f of 5, but now I want to go backwards. So remember, if you're going backwards from the original piece, you want to subtract off some derivative values. Now, the difference between 5 and 4 is only 1, so we only want to go 1 step back. So I'll even put 1 times, but you don't have to put that if you don't want to. So that'll be the 5520 minus 109, 109.3. So f of 4, our estimate for it will be, whoops, not multiply, subtract. 5,411.03. Ooh, and it's already 12:30. But again, this one was packed with a lot of different pieces, which is what I was going for. Questions, concerns about any of that? I'm gonna unhighlight those. No, I'll keep those highlighted. I'll keep it highlighted. Let me just clean it up a little bit. That last one's a little. There we go. All right. Let me think for just 1 second. Okay, then we'll just keep going. Again, we'll get through as much as possible, and if we don't get through it all, which I don't think we will, I'll post the answers to the rest of it on Blackboard when I get the chance. So I'll leave this up for a couple seconds before I start it in case anyone wants to write it down, but essentially a shoe company pays $3,000 every month for materials. Each pair of shoes costs $25 to make. They sell the shoes for $75. Assuming the functions are linear, find cost, revenue, and profit. For 1 month, that just means that we don't need to consider that 3,000 more than once. That's all that's saying. And then we're going to find the break even. So I'll wait like 5 seconds, maybe 10 seconds. And then we'll jump into that. All right, so if we're assuming they're linear, our cost, our cost function, remember that's made up of our fixed plus our variable. So our fixed cost in this case is the 3,000. Why do I have plus? Why can't I write? So we have our 3,000 that gets paid no matter what, and then $25 per pair of shoes. And then our revenue is, remember that's, let me just write this for just review sake, so fixed plus variable. Remember that revenue is price times quantity, which is sometimes used in those ones where we're given the demand or the supply function. But in this case, it doesn't matter. They just tell us if they sell them for $75, so it'll be 75Q. And then our profit function, remember, is revenue minus cost. A lot of people get that backwards. So revenue minus cost, so 75Q minus the 3,000 plus 25Q. So remember, you should put parentheses around that cost equation, or else you might forget to distribute the negative. So we'll have 50Q minus 3,000 as our profit function. And then we want to find the break-even point. So the break-even point, there's two ways to find that. So that's either when revenue equals cost, or why did I put that in parentheses? When revenue equals cost, or when profit is equal to 0. They're both going to find you the same number. In this case, we have the profit function, but usually this is often calculated with revenue equals cost. You usually don't find the profit function first, so I'm just going to go ahead and do it that way. Again, it would not matter if you just originally set profit equal to 0 either. It's going to get you the same number. Because essentially what I'm going to do is I'm going to subtract this 25Q from both sides. So we'll get 3,000 equals 50Q. And if you think about setting this 50Q minus 3,000 equal to 0, the first thing you would do is add the 3,000 over to the other side. So you would get right here anyway. So we have that. And now if I want to solve for Q, I'm going to divide both sides by 50. So 3,000 divided by 50 is 60. I could have done that in my head. But remember, for me, when I say break-even point, and usually I'll bold it, I forgot to bold it here, I always, whoa, what is that? I always want the break-even quantity and the break-even price. Remember, break-even point is technically made up of two things. So not only do I want this Q equals 60, but now I want the price associated with it. So remember, for the break-even price, you'll take that Q value and plug it into revenue or cost, not profit. If you plug it into profit, you're going to get 0, and I don't care about that. That is technically your profit there, but I want to know the, the cost you need to put in or the revenue you need to make before you break even. I always prefer to plug it into revenue because it's usually a simpler function, but whatever floats your boat. So 75 times 60 get us 4,500. So the price, I'll just write P, would be $4,500, and this would be what are we on? We're selling that pair of shoes deal, pair of shoes. So 60 pairs of shoes. So our Q value here is technically one pair of shoes. So 60 pairs of shoes, and they have to make or they have to put out in cost $4,500. Questions, concerns about that one before we do the next one? I think the next one is the last one we'll be able to get to. But that's okay because the ones we have covered a lot. So. All right, let me scroll down. Let me leave that last piece in there. And I'll give you all like 10 seconds in case you want to write at least the important bits of this down. So I used X's here instead of Q's just because I wasn't thinking about it, but so we'll use X's since it's written that way. But we essentially have a rival shoe company who finds that their revenue function is given by 2x squared plus 15x, and their marginal cost is 6x minus 35, and they know that their fixed costs are $75. So the first thing we want to do is find the company's cost function. So we're given the marginal cost. Remember, marginal cost means that it's the derivative of the cost function. So if we want to find the actual cost function, we need to essentially take its antiderivative. But then remember, with antiderivatives, well, I'll talk about that in a second. So we essentially want to take the antiderivative of this marginal cost. Whoops, I'm using x's. Of this marginal cost equation. So our antiderivative here, we add 1 to the power, divide by the new power, now using our antiderivative rule. So sorry, the 6 comes along for the ride, then add 1 to the power, divide by the new power. Antiderivative of 35 is 35x. Always add a plus c to your antiderivatives. That was something that I got a couple people on exam 3. I always want the plus c on your antiderivatives. Oh, also, before I forget to mention it, if you want to see your exam 3, just shoot me an email and I can scan it to you. And again, I'll be posting the answers when I get a chance, either today or tomorrow. So maybe I shouldn't use c there. Can I use a k here instead of a plus c because it's a cost function? So that's my constant at the end. So then the fixed costs are 75. So essentially that's the cost when we plug in 0. So if I clean this up a little bit, this would be 3x squared minus 35x, and then I'm going to have plus k. And so if I plug in 0 to this, and you might already recognize where it's going to go, but if we plug in 0 here, that should equal 75, because that's what our fixed costs are, and the fixed costs is when you make no things. Since this is a polynomial, the first two things essentially just go to 0, and we just get that that k value is 75. So our cost equation would be 3x squared 35x plus 75. Questions, concerns about that? And we'll have maybe enough time for this last one. All right. So the next thing we're asked for is to find the production level that yields the maximum profit, and what is that maximum profit? So this is a chapter 4 question. So if we want to maximize profit, the first thing we need is the actual well. So remember, when you want to maximize something, you would technically want to find the derivative and set it equal to 0. So we can do that here, but remember, we have another option when it comes to this, because this is technically marginal revenue minus marginal cost. So now I'm going down instead of up. So we could also marginal revenue equal to the marginal cost. And let's go ahead and do that way. You could find the profit function, find the derivative of the profit function, and set it equal to 0. Would find the exact same thing. But here, specifically because we're in cost, revenue, and profit question, we can also find the possible maximum or minimum points by setting the marginal revenue equals to the marginal cost. So we have the marginal cost already. That was just given to us. So the marginal cost was 6x minus 35. And we're going to set that equal to, I'm going to kind of space it out kind of weird, equal to marginal revenue. Now, marginal revenue we actually have to find really quick, because we were only given the regular revenue. So the regular revenue was 2x squared plus 15. So marginal revenue, switch back to derivative rules, bring the power down, subtract 1 from the power. Derivative of 15x is 15. So we're setting marginal cost equal to marginal revenue. Again, you could find the actual profit function because you have the actual cost function and you're given the original revenue. So if we set these two equal to each other, I would subtract the 4x. I'm going to run out of space if I don't start writing a little smaller. We'll get 2x minus 35 equals 15. Add the 35 to both sides. 2x equals, I should be able to do that in my head. Was that 50? Yeah. So x equals 25. I'm not done, but questions, concerns so far? Okay. So now we're asked for maximum profit. Now this is technically a global max-min question, so we need to talk about the interval we're working over. So if we think about our x values, what's the smallest x could be if this is a amount of shoes? Well, we could make 0 things, but then we can make as many as we want. So our interval we're working over is 0 to infinity. Remember, whenever you're working with a maximum global maximum in question, if it includes an infinity, you need a number line. Remember, if it doesn't include infinity, that's when you take your endpoints and your critical points and you plug them into the original equation and compare the y values. But we need a number line here. That's going to be a derivative number line. So actually, I'm going to still need the derivative of profit. I'll find that in a second. And so I'm going to cut this off at 0 and put my critical point of 25 on there. So I'm going to jump back to the right corner and find the marginal profit really quick. So actually, we were going to need that, so I should have just found that to begin with. This is marginal revenue minus marginal cost. So since I have the marginal things, let me just go ahead and find it that way. So we have the marginal revenue was 4x plus 15. Marginal cost was 6x minus 35. So the profit function, so 4 minus 6 gives us negative 2x. And then 15 plus 35, when we distribute that negative, will give us 50. Why did I need that? Because remember, when we're using our number line, we need to plug the numbers into the derivative. So the numbers I need to plug in, I need to plug them into this negative 2x plus 50. So I pick some test points. Oh, that's a thicken. So I don't know, let me pick 1 and I don't know, 50. That 1 looks really silly. 1. We're going to plug those into the derivative of profit. So we'll get negative 2 plus 50 equals positive 48. And then 2 times 50 is 100, so negative 100 plus 50 will give us negative 50. So that's negative. So increasing and then decreasing, because remember, if the derivative is positive, the original is increasing. If the derivative is negative, the original is decreasing. So since that kind of shape tells us that it's going to be going down forever in both directions, we actually can have a global max. So since we can have a global max, we will have a global max. Max at 25. And then we wanted to know the actual profit at that point, which again, I didn't originally find the profit function, but we'll need it now. So the original profit function at 25. But since I have revenue and cost, I'll just calculate it as revenue minus cost. So revenue, regular revenue at 25 is going to be using this 2x squared plus 15. So 2 times 25. Do I have enough space to write that? I think I can. So this will be 2 times 25 squared plus 15 times 25 minus a lot of stuff I'll figure out in a second. Plus 15 times 25. So 1625. And then our cost equation was back up in the first part of the question. So 3x squared minus, so let me write that down before I forget, 3x squared minus 35x plus 75. Okay. Scroll back down. So 3, oh, I'm still writing in red. So 325 squared minus 35 times 25. Ah! No! Made it. And so that will give us 3 times 25 squared minus 35 times 25 plus 75. Be 1075. That's not a lot of profit. Their profit is $550. That's not a lot, but oh well. I pulled these questions off the top of my head, so. All right. Obviously we're out of time. So the last two sets of questions I had on here, this one was focusing on chapter 4 material, max min inflection points. And then the last one was focusing on more chapter 5, chapter 6 material. So I'll finish those out and post those on Blackboard in case anyone wants to look those over. If you have any questions, feel free to stick around for a tiny bit before my next class. Otherwise, the next thing you'll need is to take the exam in a week. We don't meet again. Remember, I have those office hours. I'll be posting those in an announcement on Blackboard in case you want to talk about anything before the exam. Remember, you have homework that's due on Wednesday. And now I'm done. Thank you, Gwen. Riley, I haven't written it yet, so I'm not entirely sure. It'll probably turn out to be about, I think my finals usually turn out to be like 30-ish. Like my normal exams usually turn out to be 15-ish, and it's going to be about twice that length, so maybe 30-ish questions. Which should hopefully, I'm going to plan for it to only take you an hour and 45 minutes for a quote unquote average student. But you'll have the 2.5 hour window to take it in.